All right, so everybody with me? So I'm getting this homework 3.1. This is found on the first page of mathexcel.com under the word announcements. I can't say announcements. Okay. Right, so you click on announcements and you'll find homework 3.1 trig identities. So this is due on Wednesday. What is due? The work. So I'll give you credit as I see the work. I don't want to just see the answers. You got the answers. We got the answers. Everybody's got the answers. I want to see the work that leads to the answers. That's how I'll know you really worked on it and give you homework credit for that. And I'll be doing as many as I can in the next half an hour. So I want to see the work. So yeah, copy these down as we go. You get half your homework done right now. So, all right, so that's where it is. Let's start with number 1 there. Secant x minus 1 over secant x. So number 1, secant x minus 1 over secant x. So let's look back. You've got the answers here, sine, different stuff. All right, so how do you do these? You look at that and you go, what am I even supposed to do? Well, there's a lot of different things. I know this is hard, and I'm gonna show you what I can. Oh yeah, let me also say 5 of these exact problems are on exam number 3, Wednesday. 5 of them, exactly 5 of them. No changes at all, other than the answer option order. Those would be the only trig identities. All 5, there's only 5 trig identities. I know it's not only 5, but there are exactly 5 trig identities. They're all from here. I won't take them from anywhere else. So if you master all these, you got all the trig identities down for the exam. And I'll do as many as I can. All right, so how to do secant minus 1 over secant? Well, there's a lot of different things you do. One of the things is change to cosine. I think we did this one, didn't we, real quick or something? Yeah, so secant, remember, is 1 over cosine. And 1 over secant is just cosine. Is that always what you do? Not always. I know that's what's tricky about these, but often. Often if you see secants and cosecants and stuff like that, you change them. Remember, secant is 1 over cosine. It's upside down a cosine. So I do that. Everybody good so far? Now what are you supposed to do? Well, if you look at the answers, let me help you. What you want to do is kind of keep one eye on the answers. And you look at the answers and you go, okay, wait, now, looks like look at them, most of them, this one, and this one, are like one thing combined. They're not 2 things added, are they? Everybody see A? Now, I know D is 2 things added. But A, B, and C are 2 things times, aren't they? So they changed from like added, subtracted to times. So in other words, I should combine these 2 fractions. That's what leads me to think, oh, put them together into 1. So put this over 1, so it looks like a fraction, and combine those with a common denominator. What's the common denominator? Multiply top and bottom of this one by cosine. So then they both have cosine denominator, don't they? What is that going to be? 1 minus cosine is cosine squared over common denominator cosine. Good so far? I just did common denominator there. Multiply top and bottom to make them both have common denominator, then put them together into 1 fraction, and then as soon as you see 1 minus cosine squared, remember, sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. Remember that relation? You want to that's going to come up all the time. You want to just recognize that. 1 minus cosine squared, oh, that's sine squared. I just replace that with sine squared. Everybody see that? Now, the hard part about identities is you can get all the way to here, look back and go, I've surely got it now, and you look and you're like, I don't see any of those. It's still not there. Right, and that's the hard part. What else do you think? What can I do? Well, it looks like they have a lot of like tangent and cosecant and cotangent. So anyway, I could do, and it looks like they have like a sign in the front. Could I say, hey, look, leave 1 sign in the front times sine over cosine. So everybody see this is the same as that. Why? Because sine alone is over 1, isn't it? Right? This is over 1. That's sine squared, 1 times cosine, cosine. That's the same thing, isn't it? Everybody see that? And what's this? What's sine over cosine? So this is sine times tangent. There it is. That's answer A, isn't it? Yeah. Sine times tangent. Everybody see that little trickery? I took sine squared and I just said, look, I can pull sine to the front times sine over cosine. That's sine squared over cosine, and that's tangent. Good? Is that okay? That takes practice. All right, let's go to number 2. Let me get it in front of me so I don't have to keep going back and forth. So number 2 is cosecant. I'm going to get rid of the x's. Times sine plus cosine. So this is what I want to see on a separate piece of paper. I just want to see this work turned in on Wednesday for credit on that homework. So that makes sense? Just show. It doesn't have to be my exact work, but some work which logically leads to the answer. All right, so how do you do this one? Well, number 2. Well, as soon as I see cosecant, what am I going to do? Cosecant is equal to 1 over sine, right? So whenever I get secant, it's 1 over cosine. Cosecant's 1 over sine. Put those on your 3x5 card. 1 over sine times sine plus cosine. Good so far. And now distribute. So 1 over sine times sine. What's going to happen? Remember, whenever something that's a fraction interacts with things that are not fractions, put them over 1. Make them look like fractions. So 1 over sine times sine over 1 is sine over sine, plus 1 times cosine is cosine over sine times 1 is sine. Good to there so far? How we doing? Is it a little warm in here? Yeah. Not funny, huh? I guess it's not too bad. All right, so good to there? Now, sine over sine, that's just 1. What's cosine over sine? Cotan. Yeah, do you know that's cotan? Tan, remember, is sine over cosine, and cotan's upside down. So it's cosine over sine. So you want to have all those in your 3x5 card. 1 plus cotan. Hopefully that's there. Is that the answer? Yep, B. That's answer B. We got it. All the answers are on the end of the handout for you. So you'll know when you got it right. Is that good? Everybody see what I did there? I'll move on. I'm going to go on, probably kind of quick. This will be on YouTube. Let's go on to number 3. So I want to get as many of these done as I can for you. So we're doing your homework right now. Go ahead and copy it down. You can just turn this into me on Wednesday at the test. As far as we get, just do the ones we don't get to. All right, so number 3. We're supposed to add those two fractions. What do you do to add fractions? What do you need? Common denominator, right? Common denominator. So, you've got to take this guy and multiply top and bottom by sine, this guy and multiply top and bottom by cosine. Then they'll both be sine cosine. See how that makes both denominators sine cosine? Common. So both denominators are sine cosine. It doesn't matter what order, you put cosine first and sine, whatever. What's the top? Sine times sine, sine squared. Cosine times cosine, cosine squared. Good so far? All I did there was common denominator. That's pretty typical. Whenever you have two fractions added, do common denominator. We good to there? Now, do you recognize that one? What is that? 1. Good job. Yeah, so that's there's a few you really want to put a few of these on. So sine squared plus cosine squared is 1. That's another one you want to have on your 3x5 card. How's your 3x5 card doing? Is it getting big? So put that in there. So we have 1 over sine cosine. Good so far. Now, as you look at the options, I'm looking, here I'll look with you. The options on number 3. here. Let's erase all this here. So the options on number 3, I'm looking going, sine tangent, tangent. Hey, that looks maybe secant, cosecant. Isn't that what I have?
Yeah, that's the answer.
Yeah, 1 over, because this is 1 over sine. What's 1 over sine? Cosecant. And you can put another 1 up here. I mean, 1 on the top is 1 times 1, right? That's secant. Everybody see that? Right? Is that too fast? This is the same as just breaking it into 2 fractions. 1 over sine times 1 over cosine. That's still just 1 over sine cosine. And that's cosecant, secant. See that? That is D on that one. See what I did there? Changed it back. That okay? Questions? All right, so number 4. So one of these things, it always looks doable, when it makes sense when the teacher does it. I experienced that too. You really have to try this on your own as well before the test on Wednesday. All right, over to here. What should we do with this? I have no idea. Let's just foil out that top and hopefully something nice will happen. So I'm just going to take that top and say, okay, that's sine. I always just get rid of the x. I just want to save space. That's totally fine with me if you want to do that. It's fine with me if you want to call them S and C. Yeah, maybe I'll do that too. I'm gonna just make it S and C. Maybe that's too casual, but I want to move fast and keep it clean. So it's S plus C times S plus C, 1 over 2 times SC. Over 1 plus 2 times SC. Good? Like that? Right, because whenever you have parenthesis with a square, you have to write 2 of the parentheses, don't you? Everybody good with that? In other words, you can't just say it's sine squared plus cosine squared. That's a really, let me pause right there. I remember my daughters making that mistake for like a whole year when they were doing trig and pre-calc, and I would sit at the kitchen table with them. They would have something like this, and they would be, especially with pre-calc, they would be doing that, and they would go sine squared plus cosine squared. I'd go, nope, girls, that's still not true. Like the other 10 times you tried it. Still not true. Now my daughter, Lizzie, says she never did that. She's in calculus now. And says, I never did that, did I? No, you did that. You did that like 10 times. All right, anyway, so it's a really easy mistake to make. So watch out for that, right? Really, you have to write 2 of the parentheses. You can't just square the individual pieces. It's not true. So you got to write 2 of the parentheses. You got to FOIL the whole thing. So, all right, so let's crank it through now. So this one goes to both. Sine squared plus sine cosine, boom, boom, plus cosine sine, plus cosine squared. Can you tell my S's from my C's? I'm a little sloppy there. Good there? And then these 2 are like terms, aren't they? It's 1 and 1 makes 2. Sine squared plus 2 sine cosine plus cosine squared. Is that good so far? Am I going too quick? See, that was like term. Remember like terms from algebra? When you have the same letter pattern, sine, cosine, cosine, sine. That's the same thing. The order doesn't matter, right? It's just 1 sine cosine and 1 sine cosine is 2 sine cosine. Just adding like terms, adding the numbers in the front. When does it become, when does sine cosine and sine cosine become sine squared cosine squared? Why didn't these 2 become sine squared cosine squared? Because they weren't multiplied. It's when you times them that you change powers, right? If you're adding them, you just add numbers in the front. Everybody good with those rules from algebra? It's just like terms, just add the numbers in the front. Don't mess with powers when you're adding letter expressions. You only change powers when you're multiplying. All right, so now what? Do you see it? What is this plus this? What are these guys? 1. Remember? Sine squared plus cosine squared is 1. So these guys become 1 plus 2 cosine plus 2 sine cosine over 1 plus 2 sine cosine. It's a big fancy 1. All of that. It's a big fancy 1. Everybody see that last step? right? The sine squared and cosine squared, put them together, they're 1. And that whole thing's a big 1, therefore. Right? Same thing over itself. Big fancy 1. Questions on that one? I'll move on. All right, number 5. Number 5, okay, 2, I'm just going to make a t here. 2 tangent minus 1 plus tangent quantity squared. Okay, here it is again, parenthesis. What are you supposed to do? This is a pretty hard one because of that minus in the front. So easy to get messed up. Leave that minus here and FOIL out. Remember, you got to write 2 of the parentheses. Don't make the mistake my daughter's made for a year. Right? You got to write 2 of those parentheses and FOIL that out. Right? So what do we get? Boom and a boom. 1 plus tangent. Boom and a boom. Plus tangent squared. Right? So whenever there's parenthesis with a 2 power, you got to write 2 of them and FOIL it out. So far, so good. And this is 1 plus 2 tangent plus tangent squared. Pretty good to there. And now that minus in front of the parenthesis, he's going to distribute, changing all 3 signs, won't he? Minus 1, minus 2 tangent, minus tangent squared. Good? So right now I'm just FOILing out, distributing minus signs. Now, what can I do?
Cancel out.
2 tan, 2 minus 2 tan, bye-bye. So it's minus 1 minus tangent squared. Good to there. So all this has just been algebra up to now, right? Just FOILing and like terms and distributing minus signs. This is all algebra. Now comes the trig. When you see that 1 tangent squared thing, there needs to be a formula on your 3x5 card. 1 plus tan squared is secant squared. You got to have that and the cotan version. 1 plus cotan squared is cosecant squared. You want to have those 2 on your 3x5 card. And you go, yeah, okay, but what about these minus signs? Yeah, you can factor out the minus, can't you? Factor out the minus, and it's 1 plus tan, bless you, 1 plus tan squared. Everybody with me? Right? See how I factored out the minus? And then 1 plus tan squared? Secant squared. Minus secant squared. That's probably there somewhere, right? Yeah, that's D. That's option D. Everybody see that? So when you see that 1 plus tan squared, that's what's hard. You got to have them all on your 3x5 card and then remember it. So there's just a few. I mean, it seems like a lot, but really it's sine squared plus cosine squared is 1. And then the sine squared is 1 minus cosine squared and vice versa. And then 1 plus tan squared is secant squared. Those are the main ones that we mainly use. And then the upside down ones, like secant is upside down cosine and cosecant is upside down sine. That okay? Questions on that one? Let's keep moving. Just under 15 minutes left. Number 6. Tangent times cotan minus cosine. All right, what should we do with this one? We should definitely just multiply. I'm just going to go boom, boom. So I'm going to have tangent times cotan minus tangent times cosine. Good so far? I just distributed that tangent. Distribute on through the parentheses. Okay, now, any ideas? Yeah, break into sines and cosines at this point. Break into sines and cosines. Really good idea. Tangent, remember, is sine over cosine. And cotan is upside down of that, right? Cosine over sine. Minus, and then tangent is sine over cosine times cosine. It's often a good idea just to break down into sines and cosines. It's good to there so far? And now, see what happens? Cosines cancel, sines cancel. It's a big 1 over there. And that makes sense. Tan times cotan, they're upside down. It's 1. And what happens? It's like good so far. What happens over here now?
Just science.
Yeah, because this guy's over 1. Remember, whenever a whole number or whole whatever interacting with the fraction, put it over 1. Cosines cancel. It's just sine over 1. It's just sine. 1 minus sine. We're done there. Now, I assume that answer's there. Yeah, it's D. Now you might say, well, let me tell me what's wrong with this. You might say, oh yeah, 1 minus sine, that's cosine. We learned that formula. Not true. Why not? What's wrong with that? 1 minus sine squared would be cosine squared. You can't. There's no such formula for regular sine and cosine. It just stays 1 minus sine. We're done. Good. All right. Number 7. So sine squared plus sine squared times cotan squared. Okay. Sine squared plus sine squared times cotan squared. What do you think?
Cotan into cosine over sine.
Yeah, break down the cotan into the sine cosine version. Yeah. So, right, because all the trig functions can be made out of sines and cosines. Everybody hearing that, tracking with me? Really, all of trig is sine and cosine. Have you picked that up? I should have said that a long time ago, probably. All of trig is really just sine and cosine. Everything else is just made out of sine and cosine, aren't they? Tangent is just sine over cosine. Cotan's upside down. Cosecant's 1 over sine. Secant's 1 over cosine. Sine and cosine is trig, really, isn't it? So you can always just break everything down to sine and cosine. The rest are just Johnny-come-latelys. So cotan breaks down to cosine squared over sine squared. Like that. Good to there. Okay, now what can I do over there? Everybody see? This is just sine squared. What's going to happen here? This is over 1 again whenever a whole number is interacting with a fraction. Cancel. Cosine squared. And what's sine squared plus cosine squared? 1. There we go. Now, when I say I'm going to put the exact same questions on the real exam Wednesday, I'm lying. No, I'm kidding. I'm not lying, but let me be clear what I mean by exact. I mean it'll even have the same options, except I'm going to add E, none of the above, and I'm going to mix them up. So you can't remember, oh, when I see this one, it's A. No, it won't. It's going to be mixed up order, but it will be the same answers, but I'll throw in none of the above. So, for example, what I might do is make up some goofy answer for A, sine times tangent or whatever, and then put E, none of the above, and the real answer will be none of the above because it's 1 and it's not there. Are you tracking with me? At least one of these will probably be none of the above because E is 1 out of 5 options, so about one out of about 5 questions is E, none of the above. So probably one of these will be none of the above. So don't be alarmed. I want to be up front with you, right? You might do this. I remember this one. It's 1. It's not there. It's not there. Right. I made it none of the above. Maybe. Right? So that's what I mean. All right. So don't be alarmed. I'm not meaning to alarm you. Just want to make sure you know what you're doing. It's my job to test that you really know what you're doing, but I don't want to alarm you. All right. When you do know what you're doing, I want you to get the points. So let's try number 8 here. Sine squared plus tangent squared plus cosine squared. And so what should we do on that one? Any thoughts? Ulysses, right? What do you think?
1.
Yeah. Good job. You guys getting the hang of these. That's sine squared plus cosine squared. Put them together 1, right? Starting to see these more. The more you work through these on your own, you'll start seeing them. It's just comfort of seeing them again and again and again. Sine squared plus cosine squared, that's a 1. It's funny how much of life really is practice, isn't it? Just doing it, and pretty soon your mind starts recognizing these things. So those two make 1. And then 1 plus tangent squared. You starting to recognize that one? Yeah, 1 plus tan squared is secant squared. So this is secant squared. Hopefully that's it, and we're done. We don't have to mess around. Yeah, B. There it is. We got it. That good? Getting a little more comfortable. Okay, I'll go on to number 9. Cosecant times cotan over secant. Okay. What do you think about one like that? I'm thinking break it down to all cosines and sines. Because it's all them weird things, cosecant, cotansecant. Make them all sines and cosines when you see that kind of thing. Shows you a good plan. So what's cosecant? 1 over sine. What's cotan? Cosine over sine. And what's secant? 1 over cosine. Good so far? I just broke them all down. Remember, all trig is sines and cosines. So what? What now? Well, couple things. On the top, I can multiply. 1 times cosine is cosine. Sine times sine is sine squared. Over 1 over cosine. Good so far. I just multiplied the top. I probably wrote too much, made it look worse. Just multiplied the top together, right? Just times, big times there. Now, what do you do when you have a fraction on the bottom of a fraction? You remember? Flips up. It flips up and then becomes times, right? It's upside down multiplying. We know that. Times cosine over 1. Flip it up. Remember, dividing is upside down multiplying, isn't it? So then that's what? Cosine squared over sine squared. Looking at my answers for number 9. What can I do now? They all look like they've been changed back into secants and cosecants and cotans and stuff. What's cosine over sine? That's cotan. Remember? So that's cotan squared. And there's our answer. Because cosine over sine is cotan. It's cotan squared. Which may be none of the above on the real exam. I might erase cotan. I did some of that. I don't remember which ones I did it on. But I did it. But it's really cotan squared. So if it's there, grab it. If not, it's none of the above. Good. Other questions? All right, on we go. 10. We're past halfway. That's good. All right. Number 10. Tan. Is it tan times cotan? Yeah. So it's tan times cotan. What's that? What's tan times cotan?
1.
1. Are we good? Can I just say 1? They're upside down of each other. Right? Or if you want, you can do sine cosine thing, if that helps. Whatever. They cancel, it's 1. However you want to see it, as 1. All right, number 11. Number 11 is tangent plus 1 times tangent plus 1 minus secant squared over tangent. I'm going to make that a capital T so it doesn't look like my plus signs. Tangent plus 1 minus secant squared over tangent. Okay, well, definitely let's just multiply out those parentheses. Boom, 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 boom. Tangent squared plus tangent plus 1 minus secant squared over tangent. Good so far. Gather like terms. Tangent plus tangent. 2 tangent. Just like terms, like from algebra. Good to there. Any thoughts at this point? Oh, good question. Yeah, you can't. Oh, yeah, you can't cancel when there's pluses and minuses. Have I said the Costco glue thing? Plus and minuses glue things together. So, yeah, I can't cancel tangent unless I do all of them. So I can't do that. Any recognition of these guys? These guys want to get together and make something new. What's tangent squared plus 1? Or 1 plus tangent, either way you say it. Yeah, is secant squared. So these two together vanish, and in their place comes secant squared. Plus 2 tan minus secant squared over tan. Bring it up to here. And then cancel. Huh? Everybody see that? The tan squared plus 1 vanish, and in their place comes secant squared. And then this is just 2t over t. Cancel, 2. All that just became 2, didn't it? See all that? See how we just keep using the same formulas over and over again? See if we can squeeze in one or two more. To number 12 we go. Number 12. So cosine minus sine over cosine plus sine minus cosine over sine. So what do we need to do on number 12? Common denominator, huh? For sure, common denominator. So multiply this one by sine over sine, and this one by cosine over cosine. To make both denominators become sine cosine, right? To combine two fractions, you got to have same denominators, common denominators. And so then the sine distributes, sine cosine minus sine squared, and then the cosine distributes, sine cosine minus cosine squared over sine cosine. Going too fast? Is that good to there? It's all good. Sine cosine plus sine cosine. Like terms, like algebra. 2 sine cosine minus sine squared minus cosine squared over sine cosine. Good so far? I guess will be our last one here. Okay, so what am I going to do with these guys? When you see these guys, you know what you could do? 2 sine cosine minus, factor out a 1, a negative 1, right? Because they're both negative, so you can factor a negative 1 out, and then this is 1. Because you got to make it sine squared plus cosine squared to be 1. That's what the formula says. You with me?
You put a 2 in the denominator.
Oh, thanks. Thanks, Wendy. Everybody good to there? Is that better? Everybody good now? So all that happened is I factored the negative 1 out of minus sine squared minus cosine squared to make them both plus. And then, why did I do that? Because that's 1. So that means I now have 2 sine cosine minus 1 over sine cosine. Right? Good to there? There's one more trick coming, and then we'll be done. What can I do with that now? You can break them up. I can't, by the way, I cannot cancel these. Don't do that. Oh yeah, it's probably a common mistake a lot of people make. Let me address that. I know we're basically out of time, but let me say this. You cannot go like that and go, oh, okay, it's just 2 minus 1. It's 1. Where's the 1? It's probably there to fool you. It is, huh? Or is it? No, it's not. Anyway, why? What's wrong with that? That looks great. Costco says no, right? Pluses and minuses. Glue package. It says, you want to cancel something on me up here? You go like that or you do nothing, right? I'm glued together. You buy the whole package or you buy nothing. You don't buy part of it, right? Pluses and minuses glue things together. So we can't do that really common mistake. Remember Costco. So, well then what do? You break them up over a common denominator. You know what I mean? Make it 2 sine cosine over sine cosine, right? That's just common denominator, right? 1 fraction to 2. They both have sine cosine. And now you can cancel. Because now that's all just glued. I mean, that's not glued, right? Everybody see how when you separate them into 2 fractions with the same denominator, that's just opposite of common denominator. That's just separating over a common denominator instead of combining over a common denominator, right? I just separate them. Then you can cancel. There's no plus or minus up here now. So what does that leave me? 2 minus 1 over sine cosine. Is that answer there?
No.
That is?
No.
I wanted to hear the answer yes. Let's try again, Wendy. No, I'm just kidding. And then they made sine and cosine on the bottom. That's secant, cosecant. Is that what they did? Secant times cosecant. 2 minus secant cosecant. Somewhere, right? Yep, there it is. Right, because sine on the bottom, cosine on the bottom. Secant times cosecant. There we go. All right, we made 12 of them. You got the other 6. 5 of them literally on the exam Wednesday. So Wednesday's our exam day.